Good day, everyone. So today we're going to discuss integration by parts. So integration by parts is the second main method of integration. So many of the other methods of integration use integration by parts. So it is an important method to master. So integration by parts is a method for evaluating integrals of the form the integral of f of x times g of x dx, which are difficult to evaluate using other techniques. So the method uses the following theorem. So let u is equal to f of x and v is equal to g of x. So the two differentiable functions with respect to x. Then the integral of u times v prime of dx is equal to uv minus the integral of du prime dx. So here below is the substitution method. So first, we are going to express the integrand as a product of two expressions such that one of them is easy to differentiate. Shall we say that's u? And letter B, the other is easy to integrate, and that will be our dv. So step number 2, use the beam to rewrite the integral. So the integral of u dv is equal to uv minus the integral of v du. So first, you're going to get the value of u followed by dv. So dv is actually the remaining terms after taking u. And then right on the right side, the du, and below is also the v, which is actually the integral of dv. Okay, guidelines now for selecting the u and dv. So this is almost similar to the one that I've shown in the first slide. But this one, we are trying to adopt the acronym in choosing u to be the function that comes first in the acronym of LIATE, where L stands for logarithmic function, I is for the inverse trigonometric function, A is the algebraic function, T is for trigonometric function, and E now is the exponential function. So let's try to solve some exercises using this acronym in choosing the value of u. Okay, for number 1, we have the integral of xe raised to 5x dx. So in that case, we are trying to compare the algebraic function compared to exponential function. So according to the guidelines using this acronym of LIATE, between algebraic function and exponential function, so A comes first in the acronym. So therefore, U here is our algebraic function, in which our U here now, so I will write now U is equal to X, and then dv now is the remaining terms, which is now the e raised to 5x of dx. And then write the du, which is now the derivative of x is just equal to dx. And v here is the integral of e raised to 5x dx, which is equal to 1/5 of e raised to 5x. So after that, we are going to write now the formula of the integration by parts, which is now uv minus the integral of v du. So by substitution now, we're going to write the product of u and v, that one. So the product now of u and v will give us 1/5 of x e raised to 5x minus the integral of v du, which is this one. So we have now v is 1/5 of e raised to 5x, and the value of du is just dx. Now, on the first term, the product of ub, we're just going to rewrite. So 1/5 of x e raised to 5x minus, I will write the constant multiplier of 1/5, and then the integral of e raised to 5x. So I'll write first e raised to 5x dx. And now I'm just going to write again the first term. So 1/5 of x e raised to 5x minus 1/5 times the integral now of e raised to 5x dx is equal to 1/5 of e raised to 5x plus a constant. So finally, we have now 1/5 x e raised to 5x minus 1 over 25 of e raised to 5x plus a constant. And for number 2, we have the integral of 3x plus 4 times cosine of x over 5 of dx. So the term 3x plus 4 is an algebraic function, and the term cosine of x over 5 is a trigonometric function. Between the two functions given, using the acronym of LIATE, so we have here the algebraic function and the trigonometric function. Between the two, we are going to choose now the algebraic function as the value of u. So u now is equal to 3x plus 4, and dv now is the remaining terms, which is cosine of x over 5 of dx. And after writing the u and dv, we are going to find the value of du, which is now the derivative of 3x plus 4 is equal to 3 dx. Then the integral now of cosine of x over 5 of dx. So we have v is equal to the integral of cosine is sine, but there is a coefficient of 1/5 in the angle. So take the reciprocal of that. So it becomes now 5. And then the integral of cosine is sine of x over 5. Then after that, we're going to write the formula. So which now uv minus the integral of v du. So I will just write the answer here. So the product of uv now is 3x plus 4 times 5 sine of x over 5. So I can write now as 5 times 3x plus 4 times sine of x over 5 minus the integral of v du. We have v is 5 sine of x over 5 times the du now is 3 dx. So we're just going to rewrite the first term or the product of uv, 5 times 3x plus 4 times sine of x over 5 minus, let us simplify this one. So 5 times 3 is 15. So I can write now 15 as the constant multiplier. Then the integral of sine of x over 5 dx. So start first with the angle, take the reciprocal of that, and that will become now times 5. And then the integral of sine function, we have the negative cosine of x over 5. So simplifying that again, so rewriting first the product of uv, so 5 times 3x plus 4 sine of x over 5. 15 times 5 is 75, but negative times negative is positive. So we can now have positive 75 of cosine of x over 5 plus a constant. In number 3, we have the integral of sine x ln of cosine x dx. So we have here the trigonometric function and the natural logarithm. According to the acronym that we are going to follow, so we choose now the logarithmic function compared to trigonometric function. So we choose now u as the logarithmic function. So in this example, our u now here is ln of cosine of x, and then dv is the remaining terms, which are sine x dx. So we have sine x dx. And then the derivative of this will become 1 over cosine of x, and times the derivative of cosine x is negative sine x dx. So in other words, the product there is equal to the negative sine x over cosine x dx, or we could write the negative of tangent x dx. Then our v is from the integral of this. We have the integral of sine x dx is equal to the the negative of cosine x. Now, writing the formula, so I will write first uv minus the integral of v du. So the product now will give us u times v, this one. We have the negative of cosine x times ln of cosine x minus the integral of v du. I have the negative of cosine x times, I will use this one instead of the simplified form because I have something to cancel after all. So I can write now negative sine x over cosine x dx. So rewriting the product of uv, I can just have negative cosine of x times ln of cosine of x. Negative times negative is positive. Then cosine times sine x over cosine x. So cosine x will be cancelled, or that is 1. So minus the remaining term now is the integral of sine x dx. So finally, we can now write the answer of negative cosine x ln of cosine x minus the integral of this is the negative cosine. Negative times negative, it becomes now positive of cosine x plus a constant. Okay, in number 4, we have the integral of x times the square root of x plus 2 dx. In this case, they are the same algebraic function. So we cannot use here the acronym that we are trying to follow, the LIATE, since the given is both algebraic function. So in that case, I will try first u is equal to x, and dv will be the remaining terms. We have the square root of x plus 2 of dx. And then the du now is just equal to 1 dx or dx. And then the integration of the square root of x plus 2 will give us now 2/3 of x plus 2 to the power of 3/2 by applying the power rule. Now, we are going to write the formula in order for us to be guided properly. So uv minus the integral of v du. So by substitution now, our u times v is 1. So we have 2/3 of x times x plus 2 to the power of 3/2 minus the integral of v du. We have 2/3 of x plus 2 to the power of 3/2 times dx, the value of du. So simplifying the second term, so I will just rewrite only the product of uv times 2/3 of x times x plus 2 to the power of 3/2 minus 2/3 times, we have x plus 2 to the power of 3/2, that is now x plus 2 to the power of 5 over 2, and take the reciprocal of 5 over 2 to be the coefficient here. It becomes now 2 over 5 and then plus a constant. So simplifying further on the second term, so the final answer now will give us 2 over 3 of x times x plus 2 to the power of 3/2 minus 4 over 15 times x plus 2 to the power of 5 over 2 plus a constant. So the final answer now is 2/3 of x times x plus 2 to the power of 3/2 minus 4 over 15 times x plus 2 to the power of 5 over 2 plus a constant. So in number 5, we have the integral of ln of x dx. So in this case, our u is equal to ln of x, and dv now is just equal to 1 dx or dx. And du now, we have 1 over x of dx or dx over x. And our v here is the integral of dx, that's just equal to x. So using the formula, we have uv minus the integral of v du. So by substitution, we have now the product of UV is, we have x ln of x minus the integral of x times 1 over x dx. So simplifying the integrand, we have now rewrite first the first term minus the integral of dx. So we have now the final answer of x ln of x minus x plus a constant. Or you're going to factor out the common factor, which is x. So we can write out x times ln of x minus 1 plus a constant. So I will just write here the word or. Okay, in number 6, we have the integral of x raised to 5 times the square root of x cubed plus 1 of dx. So first of all, I would like to attempt first the value of u as x cubed plus 1. Then if I'm going to take the derivative of this, it will give us now 3x squared dx. But in our given, we have x raised to 5 of dx. So in order for us to obtain x squared dx, I need to factor out the x raised to 5. In such a way, there's a factor of x squared. So in that case now, I'm going to rewrite the given as x cubed times the square root of x cubed plus 1 times x squared dx. Because x cubed and x squared, when you multiply that one, it gives us now the product of x raised to 5. Now, from here, from this given now, I can write now my u and dv. So my u in this case, x cubed, and dv is the remaining terms. So we have the square root of x cubed plus 1 times x squared dx. And then our du, so the derivative of x cubed is just equal to 3x squared dx. Now in solving for v from dv, so I'm going to use another variable. Shall I say I'm going to use w is equal to x cubed plus 1, and dw now is equal to 3x squared dx, wherein the x squared dx is visible in our given. So somewhat like the w and dw here is the one that I attempt it first. Okay, I just don't like to use u in order for us not to be confused from the formula of uv minus the integral of v du. Now, let us solve the value of v using the power rule at the same time substitution method. So we have now the integral of this will be u to the power of 1 half times the meaning of x squared dx. So we can solve here x squared dx by dividing both sides by 3. So we can write now dw over 3. So I can write here dw over 3, or v now is equal to 1/3 times the integral of w raised to 1 half of dw. So to solve for that, applying the power rule, so we can now write 1/3 times w to the power of 3 halves, and the coefficient here now will become 2/3 because we take the reciprocal of 3 halves. So v now is equal to 2 over 9 of w raised to 3 halves. But w is x cubed plus 1. So I can write now 2 over 9 times x cubed plus 1 to the power of 3 halves. Now, that's only the solution for solving the v. Now, we are going to use the formula for the integration by parts. So we have here, I will write here on the left side, so uv minus the integral of v du. So we can now write the product of u and v. So this is our u and this is our v. So we can write now 2 over 9 times x cubed times x cubed plus 1 to the power of 3 halves minus the integral of v du. minus the integral of 2 over 9 times x cubed plus 1 to the power of 3 halves times the value of du. Now we have 3x squared dx. So simplifying the second term, so I'll just copy this one. Okay, so I will write now 2 over 9 outside the integral sign, and then I'm going to use the u du here because the u is still the same as x cubed plus 1, and the derivative of that is 3x squared dx. So I can write now as u to the power of 3 halves, and 3x squared dx now is our du. So it looks like simpler on the second term, so we can now integrate to that. So rewriting the first term, I have 2 over 9 of x cubed times x cubed plus 1 to the power of 3 halves minus 2 over 9 times u to the power of 5 over 2, and take the reciprocal of 5 over 2 to be the coefficient. We have now 2 over 5 plus a constant. So finally, so we're just going to simplify the second term. So I will copy this one now. We have 2 over 9 of x cubed times x cubed plus 1 to the power of 3 halves minus 4 over 45, and then take the meaning of u, which is x cubed plus 1 to the power of 5 over 2 plus a constant. So for number 7, we have the integral of e raised to x times cosine x dx. Between the two functions, our u becomes the cosine x. Okay, so I will write now u is equal to cosine of x, and dv is the remaining terms, which is e raised to x dx. So du now, derivative of cosine x is the negative sine x dx. And v now will be the integral of this will be equal to e raised to x. So using the formula of uv minus the integral of v du, so multiplying that one now, we have e raised to x cosine of x minus the integral of e raised to x times negative of sine x dx. So I'll just write the continuation for this. So I can write now e raised to x cosine of x. So negative, and the negative, I put outside the negative here. It becomes now positive of e raised to x sine x dx. So in this case, we are going to solve for the second time around using the IBP. Okay, for here, I will write it here on the right side. U is equal to sine x, and dv is just equal to e raised to x dx. And then our du here for the second term. So we have du now is equal to derivative of sine x is cosine x dx, and v here is just equal to e raised to x. So solving now for the integration of the second term, so I will copy first the product of ub of the first term. We have e raised to x cosine x plus we have the product of uv. We have now e raised to x sine x minus the integral of v du. We have e raised to x, and the du now is cosine x dx. So I will rewrite the original given on the left side. We have the integral of e raised to x cosine x dx. As you can see, the left side is the integral of e raised to x cosine x dx is exactly the same on the right side. So since they are of like terms, we can now transpose the negative of integral of e raised to x cosine x dx on the left side. Therefore, it becomes positive sign. So the total of that becomes now 2 times the integral of e raised to x cosine x dx is equal to e raised to x cosine x plus e raised to x sine x. Since we're only solving for the integral of e raised to x cosine x dx, then we need to divide by 2. So therefore, we have the integral now of e raised to x cosine of x dx is equal to 1/2 of e raised to x cosine x plus e raised to x sine x plus a constant. Or if you like, you can also factor out the e raised to x. So it could be now 1/2 of e raised to x times cosine x plus sine x, then plus a constant. So in number 8, we have the integral of x cubed times ln of x dx. So in that case, our u is ln of x using the acronym of LIATE. So we have now ln of x and dv is the remaining terms which are x cubed dx. So du here is 1 over x dx or dx over x. And v now is equal to the integral of this is we have x raised to 4 over 4. So using the formula, so we can now have the product of uv will have 1/4 of x raised to 4 of ln of x minus the integral of 1/4 of x raised to 4 times 1 over x of dx. So simplifying the second term, so I can write the first term 1/4 of x raised to 4 ln of x minus 1/4 and then the integral of x raised to 4 times 1 over x. So the product now is only x cubed dx. So by simplifying, we can now rewrite the product of uv minus 1/4 times the integral of that now becomes x raised to 4 over 4, then plus a constant. So we can now write as 1/4 of x raised to 4 ln of x minus 1 over 16 of x raised to 4 plus a constant. So for number 9, we have the integral of the arc sine of x dx. So our u here is the arc sine of x and dv here is just equal to dx, and then the derivative of the arc sine of x, we have du is equal to dx over the square root of 1 minus x squared. And our v is just equal to x. So using the formula of uv minus the integral of v du, so by substitution now, so we have the product of ub becomes x arc sine of x minus the integral of x times we have dx over the square root of 1 minus x squared. So in this second term, we can write now u as equal to 1 minus x squared. And du here is equal to, the derivative of that is negative 2x dx. In that case, we can find x dx. So this one. So let us define the meaning of x dx from here. So we have x dx now is equal to du over negative 2. So we are using here the substitution method to simplify the second term. So rewrite the first term, which is the product of uv. We have x arc sine of x minus the meaning of x dx is equal to du over negative 2 all over, rewriting now the square root of 1 minus x squared, that can be written now as u raised to 1/2. Now simplifying again on the second term, so I will just rewrite now the first term. So minus, I can have now a coefficient factor of negative 1/2 times negative, it becomes now positive 1/2, the integral of u raised to negative 1/2 of du. Now, on the second term, we apply the power rule. So therefore, x arc sine of x plus 1 half times, that is now u raised to negative 1 half plus 1, that is now u raised to 1 half over 1 half, or I will take the reciprocal of 1 half, which is now 2 over 1 plus a constant. So finally, we have now the answer of x arc sine of x plus 1 half times 2 is just equal to 1, and u raised to 1 half, I can just write now as the square root of u, but u now is 1 minus x squared, so plus a constant. Okay, for number 10, so this is almost similar to my previous example in number 6. So I will attempt first that u will be equal to 4 minus x squared. And du now is equal to the negative of 2x dx. Since I have x dx and I have x cubed dx, so I need to factor out the x cubed, wherein one of the factors will give us x dx. So that will be our basis now of rewriting the given. So that can be now x squared times the square root of 4 minus x squared times the remaining factor of x cubed will be x dx. Okay, so from this given, we are now going to find the value of u dv. So in that case, our u now will be equal to x squared, and our dv is the remaining terms, which is now x times the square root of 4 minus x squared of dx. Now, taking the du, we have now 2x dx, and our v now, so to solve for v, I'm going to use this one. The u is equal to 4 minus x squared, and du now is equal to negative 2x dx. Since dv has x dx, so I'm going to solve for x dx here. X dx is equal to du over negative 2. So actually, I'm solving v in terms of substitution method. So this is my solution for that case. So we have the integral now of u is 4 minus x squared. So this can be written now as u raised to 1 half, and x dx, which means du over negative 2. By simplifying, I can write now negative 1 half times the integral of u raised to 1 half of du. So by power rule, I can have negative 1 half times u to the power of 1 half plus 1, that is now 3 halves, and then over 3 halves, or I can just write now the reciprocal of the 3 halves, which is now 2/3. So we have now the product of negative 1/3 of u raised to 3 halves, but u is 4 minus x squared, so to the power now of 3 halves. This is only the value of v. Now, after that, we are now going to solve for uv minus the integral of v du. So by substitution, our u is this one. We have x squared times v is this one. So I have now negative 1/3 of x squared times 4 minus x squared to the power of 3 halves minus the integral of v du, negative 1/3 of 4 minus x squared to the power of 3 halves times the meaning of du now is 2x dx. So 2x dx. So simplifying that one now, we have negative 1/3 of x squared times 4 minus x squared to the power of 3 halves. From this integrand, we need to solve this one using by substitution again. So let u here as 4 minus x squared, they're almost the same in here. And then the derivative of that now becomes the negative 2x dx. So I have 2x here, and I also have negative here. So I will just combine the negative sign to the 2x to come up now with the negative 2x dx to become the du. So in other words, I have now negative the integral of 1/3 times 4 minus x squared to the power of 3 halves times negative 2x dx. Okay, so that one is our u, which is now 4 minus x squared, and the du of that will give you the negative 2x dx. That's the reason why I combine the negative sign from 1/3 and to that 2x dx, so that it will come out that there is really negative 2x dx for the value of du. So after that, it becomes positive 1/3 times 4 minus x squared to the power of 3 halves times negative 2x dx. So in this case, this is now our u and this is our du. So rewriting the given now in terms of u and du, so I'll rewrite first the first term, the negative 1/3 of x squared times 4 minus x squared to the power of 3 halves minus 1/3 the integral of u raised to 3 halves. The meaning of negative 2x dx is for du. So it is now easier to integrate by using the power rule. So I will just write my answer here. So this is now copying the product of uv in the first term. I have negative 1/3 of x squared times 4 minus x squared the power of 3 halves minus 1/3 times u raised to 5 over 2 over 5 over 2, or I will take the reciprocal of 5 over 2, which becomes now 2/5, then plus a constant. So multiplying now the coefficients of u here in the second term, and that will give us now the final answer of negative 1/3 of x squared times 4 minus x squared to the power of 3 halves. So the product of this now is 2 over 15 times the meaning of u is 4 minus x squared to the power of 5 over 2 plus a constant. So for number 11, I have x squared sine x dx. So if we are going to use the guidelines of LIATE, so algebraic function comes first. Therefore, our u here is x squared. Then the remaining terms is for our dv, which is now sine x dx. So the derivative of x squared now is 2x dx, and the integral of sine x dx is just equal to the negative of cosine x. So using the formula of uv, we have now the negative of x squared cosine of x minus the integral of negative cosine x times the meaning of du is 2x dx. So by simplifying, so I will copy now the first term as negative x squared of times cosine x. So negative times negative, we have now positive. I have now constant multiplier 2, so I can write 2 outside the integral sign. And I will write first the algebraic function of x times cosine of x dx. So in this case, we're going to solve again by using the integration by parts. So for now, I will write here u again is equal to, so what I'm trying to solve here is for the second term, which is the integral of x cosine x dx. So I will solve for the second time using the integration by parts. So u now is equal to x, and dv is equal to cosine of x dx, and du is just equal to dx, and then our v there is just the integral of cosine x dx is sine x. So after determining now the u dv duv on the second term, so I will just write first the product of uv on the first term. We have negative x squared of cosine x plus 2 times the integral of uv, which is now x sine x minus the integral of sine x dx. So we have negative x squared cosine of x plus, using distributive property, so we can write now 2x sine x, 2 times negative of the integral, we have negative 2 the integral of sine x dx. So we have now negative x squared cosine of x plus 2x sine x minus 2 times the integral of sine x is negative cosine x plus a constant. So finally, the answer now will give us negative x squared cosine of x plus 2x sine x. Negative 2 times negative cosine will be 2 cosine x plus a constant. Okay, number 12, we have the integral of e raised to 2x sine e raised to x dx. So in this case, I will attempt first. So let u is equal to e raised to x and du here is equal to e raised to x dx. But I have e raised to 2x and dx. So in that case, we need to factor the e raised to 2x in order for us to have the value of du, which is e raised to x dx. So we're writing now the given. We can write now e raised to x times sine of e raised to x times the other factor of e raised to 2x is e raised to x dx. So in this case, our u is equal to e raised to x and the remaining terms will be dv. And this is our u. So we can write now as u is equal to e raised to x and dv is equal to e raised to x of sine of e raised to x dx. Then the derivative of u, we have du is equal to e raised to x dx and v now is equal to solve for v in this case. So to avoid confusion of the exponential term, so I'm going to write that one as a single variable. So I will let t is equal to e raised to x. So finding dt, that is now e raised to x dx. So e raised to x dx, this one can be written now as dt. So therefore, we can write v is equal to the integral of sine of e raised to x. So I can write now sine of t because e raised to x is t, and then the e raised to x dx, which means dt. So it looks like now simpler to integrate. So our v now is the integral of sine t dt, which is negative cosine of t. So that is our v. Now, we are going to use the integration by parts. So we have uv minus the integral of v du. So this is now equal to, we have uv, this is our u, and this is our v. So the product now will give us e raised to x and times negative cosine of t, but t is e raised to x. So I can write now negative cosine of e raised to x minus the integral of v du. So I will write here so that you will not be confused. So I will change t to e raised to x. So negative cosine of e raised to x. So minus now the integral of v du minus cosine of e raised to x times du now is e raised to x dx. So by simplifying, we can now write the negative of e raised to x of cosine of e raised to x. So negative times negative becomes now positive. The integral now of e raised to x cosine of e raised to x dx. So in this case again, we're going to use the integration by parts again. So in this case, we're going to rewrite the given. So I will let now k is equal to e raised to x and dk is equal to e raised to x dx. So by rewriting that given, so I can write now as the negative of e raised to x cosine of e raised to x plus rewriting this one in terms of k, So that is now cosine of k times the meaning now of e raised to x dx, this one, e raised to x dx, which is now equivalent to dk. So we have now the negative of e raised to x cosine of e raised to x plus the integration of this now is sine k plus a constant. But I will rewrite the meaning of k, so which is now the negative of e raised to x cosine of e raised to x, which I'm rewriting only the first term, plus sine of e raised to x plus a constant.